Well, g'day, Max here again. Welcome back to the shop. So this will be the last video for 2019. So we've made it through our first year. Well, in January it'll be our first year on YouTube. So I think we're moving along at not a bad pace. So we're going to get our taper board out for our ring gauge, and we're going to use Joe Pieczynski's method to accurately measure the major diameter of the taper. So that's a bit of an interesting setup. So it's been a busy Christmas, for us it has. Hope you guys have all survived it. I mean, our Christmas generally seems to take about a week before we get back to normal, if that's okay. Plus the day before Christmas, our car, the great Australian Holden Commodore, blew a head gasket when the heater valve let go and she overheated. So I've been working on that, I'm still working on that, so we've got a bit to go there. Plus I did get a little bit done up on the block, so at the end I put in a couple of clips of that. So we'll get you swung around to the lathe and we'll get this taper knocked out, and hopefully all should be well. So, to the lathe. Well, g'day, Max here again. Welcome back to the shop, or the driveway. Well, the mighty Australian icon, the Holden Commodore. The lion has lost its roar. So she got a bit hot, the old thing, so let's have a quick bo peep and see what's going on. So we set our compound to as close as we can get it to 16.85 degrees. So it's not quite 17 degrees, which is 16 degrees and 51 minutes. So I'll set it to 16.5 degrees, and we have our mag base and indicator set up on the tool post here. Now the centre height of the mag base is absolutely critical for setting this taper as well. So I've set that using the height gauge, and I've just got a shim which I can hold up there. Now that shim's sitting vertical, so I know our mag base and indicator are on centre. So the next thing we do is I have on my compound slide, the camera won't pick it up, but I've got I have ascribed a zero line on my compound slide, so when I do these angles it gives me a starting point, and I just put a texture dot on the other end at my finish point, and the finish point will be determined by the reading on the dial. So I come up to my starting point. So we set a zero mark on the compound. Then I'll bring the indicator up till it's running on the lathe chuck. I'll re-angle this camera, I think, so you guys can see what's going on. So I'll set the indicator on the rear of the lathe chuck. You can do this with the indicator facing the other way and use the tailstock quill. Bear in mind your quill is a lot smaller diameter than a lathe chuck, so you're more susceptible to get a height. If you have got any little height discrepancy in your dial indicator, it will show up more on the smaller diameter of the quill than the larger diameter of the chuck. So what I'll do is I'll zero the indicator there. I'm going to run the indicator along the length of the travel that I need to be approximately, or the length of the chuck, and I'm getting 0.03 millimeters difference in reading from there to there. So it's growing, it's growing 0.03. So we'll jot that figure down because we need that error reading shortly. So what I'll do now, we have our compound. Bring it back. Whoops, okay. So we have our compound set at 0. We'll bring our dial indicator in a fair amount, probably halfway through its travel. We'll bring it in until I get a 0 reading on our dial indicator. Now, I'm working in metric because the graduations on the compound end in a whole number as it's got conversion dials, so being a metric lathe and that. So therefore I have to use the metric indicator. So what I do now is I wind the compound forward 7.295 millimeters. So what we're trying to achieve is our taper. So to accurately get our taper angle, 8.425 degrees, which is half of our included angle of the R8 taper. So that's our angle there, 8.425. What we need to know is the length of side A of the triangle. So that will be our final indicator reading. Side C, the hypotenuse, we're going to use 50 millimeters. You can pick a random number. Generally try and stick to a whole number if you can, it's easier. So what we're going to do is traverse the compound slide along 50 millimeters, and now our dial indicator reading will register side A of the triangle, and we want 7.325. But remember the error in the chuck increased in diameter 0.03, so we have to deduct that off our 7.325, gives a final reading of 7.295. Now that's side A. So we just keep adjusting our compound slide until we hit that number spot on. So we're on 0 here. So I traverse along 50 millimeters. So it's spot on 50 millimeters there. Now on our dial indicator, I'll swing you around and have a look at that. And get the glare off it. So we're at 7.295, spot on our indicator there. So that's our compound set. So the marks I was talking about earlier, I have a mark at the end of the compound and a scribe line there. And I just draw a texture line is good enough for our 50 mil. It's only a guideline because we do go off the dial graduation there to get our 50 millimeters of travel. So that's it takes a bit of mucking around to and froing to adjust the compound. I find it easier to start shallow and just keep tapping it to increase the angle. That's just the way I prefer to do it, it leaves me working only in one direction all the time. So we'll get our tool in now. We can cut the taper, but also with this job as well, our taper on our bore has to finish with an exact diameter too. So we'll get the taper cut and then we'll go through the procedure to finish up on exactly the right diameter of the major diameter of the taper. It's quite an involved mathematical process, unfortunately. That one, there's two triangles that have to be worked out, and you have to also calculate in the nose radius of the tool. We'll get the taper cut first, and then what we may do is we may just fractionally overcut the taper, or I think we'll undercut it, and then we can finish off the major diameter to its exact size, what it has to be for an R8. I want this accurate because, yeah, as I said before, this is a gauge I'm going to be using on all my R8 tapers. So I have a couple of R8 adapters, so I can use this. I'll clean this one up and I can use this to test our taper. I'll test that over a couple of adapters. I have another one here in the it's an all brick drill chuck, so it gives me, I can get an average of at least these two tapers. So let's get cutting. Okay, I had to change the boring bar. This little one here, 12mm one, the Chinese one, and this boring bar's main ambition in life is to chatter. Now, we used to have a Seco one, same size, and that was fine. So we've got a bigger Chinese one in now, so hopefully this one will be alright. If not, then we go to the Seco bar. I'll just put a new tip in this. But this one's a bit tight for size getting through, so we'll see how this one goes. Well, we better get a size so we can see where we're going. Finish this shit. Might drop another insert in this and see how it goes. Okay, we've got a new insert in that's greatly improved the finish, but I do want a bit better than that, so okay, we're back again. I had a slight interruption. We've been up at the block doing some work on the pad for the new shop. So anyway, let's continue on with our little project. I think I just looked at the clips, the last clips that I was filming, and we're roughing out the bore for the R8 taper gauge. So as I previously mentioned, I do want to hit our numbers with regards to diameters on the major diameter of the bore. So I've drawn up a bit of a guide and done the calculations to assist us in that. So I'll swing you down and have a look at this. It actually took me a while to sort of get my head around what was going on, so I'll swing you around. Okay, I'm sure if any of you guys watch Joe Pieczynski's channel, you've seen a similar drawing to this before. So we're going to use Joe's method to hit our numbers on the major diameter of the taper. So this represents the taper, this represents the front face of the part. So through several triangles we locate our tangent point, and that will give us the distance that extra we have to wind out our cross slide to allow for the nose radius of the tool. So in a nutshell, we register our tool on the OD of the part. That'll give us a given number, and then we'll take a very slight skim cut across as we bring our tool across. That will then register the front of the tool. So if we move our tool across 1.731, the nose radius here on the tool, here on the tool will be right on our major diameter of 1.250. But because of the radius, we have this distance here that we have to add on. So this represents the 1.250 of the major diameter. So there's a tangent point there, so we need this distance here, which works out to be 2 4/10, nearly 2.5, just under 2.5 thou. So we'll give that a crack and see how it comes out. It does appear a bit confusing at first, so I'm pretty confident I got it right. So we'll give it a crack. Okay, so our setup for hitting our numbers on this taper, I've got a piece of 10 thou shim stock here, which is just letting me reference the tool against the OD of the part. So what I'll do then is I'll just bring the tool back. Now if I come down to 0 on our dial, that'll put the tool right on the OD of the part. Now on our 2-inch indicator, this is what we're going to use to get our, we're going to come back 1.731. Now that'll put us right on the line where we have to be to hit our number with the taper. But we're going to go shy of that. We're going to go 1.726 because I want to leave a grinding allowance. So what we do now is we'll run the lathe and we just take the tool up to the face of the part and we just take a very light cleaning cut. Then we'll wind our cross slide back, our 1.726 on the dial. That'll put the tool in the position for the final cut. So I'll put the camera back in the stand because I haven't got enough arms to do all this at once and hold the camera. Okay, that was just a very light skim cut there. So we go 1.726. Okay, 1.7. Might run the lathe in reverse now. Sorry, the other normal forward direction in case the tool contacts. Okay, I'm just going to re-zero my cross-slide dial now. 1.726. Just in case I've got to do this in 2 cuts. I'll re-zero it here. So any cuts we come back to we're on 0 here. It's looking like a very light skim cut, so what we'll do, we'll put a bit of cutting oil on that. Because it is, the material as it is, a 4140 type steel and a very light cut, she's not going to be happy. Might bring the speed up too. Okay, that's it, we're committed, that's the last cut. Let's clean that out with a rag. Okay. Okay, well the finish isn't, no, it's alright. That's why I'm going to grind it. I do want a nice better finish in there. So we just got that's just a tooled finish in there. We haven't polished that or nothing. So we'll just do a bit of a check on some of these. I've got 3 R8 tapers here. So we'll just get an average across the 3 of them. So we've got the Sharpie marker. Blew them all up. Just a couple of wide lines on either side will do for what we're looking at. Just give that a minute to dry. Okay, we'll try the first one. Feels good. The first one we're getting contact at either end, contact at the bottom but nothing at the top. So I'd say, looking at this one, the minor diameter of the bore is bugger all in it. So it's just maybe a thou tight. Let's try one of the other tapers. This one here, we're getting contact, the base, there's lines in the middle, and we're getting contact pretty well all the way along this one. On that side, we'll try this side, we've got probably more contact at the base and a little bit up here. So that's another indicator that that base could be a thou, half a thou on the small side. And the last of all, the drill chuck. Okay, the drill chuck, we got contact right at the base and right up the other end, and again on the opposite side. So I think I'll leave it alone. I'll put a trial grind through and we'll re-blue it. If we've got to adjust it a thou or half a thou, we can do it while we're grinding it. We still have 10 thou off the diameter to play with. So what we're going to do now, before we grind it, I'm going to set up another piece of material in the 4-jaw chuck. We'll take this chuck off, we'll leave our part in, and we're going to make a plug gauge. So when we're grinding, we can still hit our numbers on our major diameter. So doing it the way we've done it, it's really just an exercise in trying to hit your numbers on a major diameter with a lathe tool. But as we're going to go to a grinding procedure, we can't use that method. So we're going to do ours. We'll make a plug gauge. Thanks to Joe Pye for showing that method. And all right, we'll move on to the next stop. Well, our major diameter is supposed to be 1.250 finished size. So we have our 10th hour grinding allowance, which brings down to 1.240. And as close as I can sit these calipers on the very edge of this hole, we're there. We've hit it spot on. So that's a good result. Well, okay, it appears we've run out of time. So what our plan is with the taper, we're going to use our jig boring grinding attachment. We'll get this set up in the lathe on the next episode, and we'll grind the idea of the taper to size. So should all come out well. We did use this once before and it ran very well. So we'll get it cranked up again. So take care. Hope you all have a great new year. Don't go too crazy on the celebrations. Oh, cheers, here's to a good new year.